Hello there again, and welcome to another session of our design pattern class. My name is Gane Emmanuel, and I'm a software engineer, and I'm going to be your instructor for this series. Today we kick off with our first video and our first design patterns, and as specified in the last video, we are going to be talking about the family of the creational patterns. Today we are going to talk about the creational patterns. We're going to mention the 5 patterns that are found within the creational pattern family, and we're going to kick off with one of them. So, without further ado, let's dive right in. In the creational pattern, there are 5 design patterns in it. There is the Singleton pattern 1, there is the factory pattern 2, there is the abstract factory pattern 3, there is the builder pattern 4, and the prototype pattern 5. Each of these patterns solve a unique problem in creating classes, which we are going to see in the next 5 videos. That said, today we are going to be kicking off with the Singleton Design Pattern. And for my ID, I am using IntelliJ, and I am using the Java language. However, the design patterns are not language specific. They are a software engineering concept, and you can use whatever language, be it Python, JavaScript, C#, C++, Rust, Go, name it. You can use them and still follow along this video. It is the same concept applied everywhere. Most of these languages have classes, they have methods, they have interfaces, and everything the Java has, most of these languages have them. However, I feel comfortable using Java. You should use whatever language you feel comfortable using. That said, I have created a generic project in IntelliJ. If you are using IntelliJ, you go ahead and create a generic project in whatever language you're using, as you are not going to use complicated dependencies. It is just basic Java or base of your language. Be it Python, C# is going to be the base language. So we're going to talk about the Singleton Design Pattern. And I spelled the pattern wrong, sorry. Now, the Singleton Design Pattern, what does it do? See, the Singleton Design Pattern solves the problem where you need only one instance of a class to exist across the project. You don't want every time you require computation from a particular class, a new object of that class is instantiated. Rather, you want that you can call one instance of that class and get the particular compute or function you need from that particular class. This particular Singleton pattern is suitable for scenarios where only a single instance is sufficient to perform the duties. For example, database connections and logging, global logging. These are scenarios that will use Singleton Design Pattern. So, how do we create a Singleton Design Pattern? How do we create a Singleton object or a Singleton class? So, let's dive right in. So, we are going to create our folder here, which we are going to name Singleton. So that's a class, sorry. So I thought I created a folder package, Singleton. There we go. And we are going to create our Singleton, let's say our Singleton class, right? So that will be the name of our class, right? And the Singleton class you want to create in such a way that only one object of that class or instance of that class exists. In Java, you're going to do something as such. So you would have essentially, I'm just going to create the basic class. What we will do is that we're going to have the variable. So we're going to have a private static, and then this will be a final class. This is to make it non-mutable, right? And the static will be to be able to access it. No, I don't think this will be static, but anyway, we are going to just go to it. I'm not cramming, but all right. So let's go. We are going to call the singleton class. So first of all, yeah, singleton class, and we're going to call this instance, right? And we could go ahead and let me say just keep it there, right, for now. And I'm just going to progressively build a class, right? So we're just going to have a public singleton. We don't need the public. We don't need we don't need a constructor here. So we need a private constructor. So the first rule of and why I'm creating again, I'm going to be explaining to you certain rules, is that in a singleton class, you want to have a private constructor, which means you want to restrict creation of that object. You don't want that somebody outside of that class can instantiate that class other than through the API you expose to be able to get an instance of that class, which you're going to see in a minute. And so we're going to create a private constructor, singleton class, which basically does nothing for now. Okay, and then the most important part is create or expose an endpoint. In this case, a method through which they are going to be able to access this particular class. And in this case, this method is going to be static. And why static? In Java, again, this is so that you understand it and can implement it in your language. In Java, when a method is static and is public, you can access it via class instantiation rather than object instantiation. For example, I want to be able to do something like singleton dot, then the method name, right? That's what I want to do. However, I don't want to do something I want to do. This is not what I want to do. I don't want to do something like singleton instance equals to new singleton, something like that. I don't want to do that. Okay, and so in singleton, then I create like a method there. Then below it, I come and do instance dot, then the method name. Then so this is what I don't want to do. I want this functionality. And in order to do that in Java, we are going to have a public method, which is going to be static, making it accessible by the class name. And then the method is going to return a singleton class, which is the instance type which we want to return, which we're trying to get. And we're going to have get instance. Fortunately for us, Java is very sensible and has returned to us method name. And we want to be able to get this particular instance, right? Now, essentially, we simply want to do, we could simply just return, right, the singleton. I'm going to show you in a minute why this is, we have to do some computation inside here. If we try to return the instance, which is this instance, you will find from a static method, and that is why. So it says that this instance cannot be referenced from a static method. And in Java, static static methods and static classes, they are going to require static fields. So you have to allocate that to static. Then comes our second problem, which means that it does not. It can be accessed via static member singleton access via instance reference, right? So blah 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 access with reference to class. and this is basically saying that Singleton class instance, something like that. However, though, you see a problem here. It says that field instance might not have been initialized, and this is the issue. So we want to equal to null. Okay. Now we don't want to instantiate anything yet. We only want to do something called a lazy loading. Again, this is just blabbing, but don't care about that. But we just want to instantiate it to an empty instance, a null instance. There is nothing there. So if we return this, what we're going to return is null. So in a singleton, what we want to do is check if this is null. And then, if it is null, then we want to put in an actual instance there. If it is not null, then we simply just want to return the instance that's already there. And again, I am going to try to, if I just try to do the singleton, so if I do system.out, this is how you print in Java, print, right, and I do singleton dot get instance, what you see is a null. It's going to show you null there, right? But you don't want null. So what you want to do is check if instance, if instance of is dot instance, am I kind of correct? Or let's say singleton class dot instance is equal to null, right? We simply just want to now add, want to do singleton dot instance. Basically, we just want to do instance is equal to new singleton class. Now we have an error. Cannot assign a value finally. Okay, so it says this value is final. Alright, so there's a problem with my initial class. Was going ahead of myself, but now that was solved. And you'll see why I want to go final here, because most of this stuff is not really needed. I'm going to do two ways to show you that. So we are going to remove the final, and it says utilization of utility class singleton, blah, blah, blah. So it's just an empty class, and that's it. Right? And then we're simply now going to return the instance. Okay? And if we try that again, we're going to get, I think, yeah, a new instance. We're going to get a reference in memory of that object. So a new singleton class instance has been created. Now, to demonstrate that an object can only get only an instance of this particular class exists. Okay, so I'm going to move those comments to be clean. I am going to create threads. I hope I can still remember this. Let me see. I'm gonna go threads. How do you create the thread? So there are two ways to do it. How do I do this? So this thread C1 equals to new thread. So new thread. Yeah. And this can go, let me see, it says intersecting a thread with the for1 method. Then I know we can do C1 dot start. Yeah. Okay. Then can we like write this like a lambda expression? Yep. Yeah, so what we can do is I can call the singleton. I can call system.out. So thread to T2, about the same thing. And so what I could do here is just, so I could do thread 2 years, and then here we have, okay, this additional code, you don't have to worry about it. This is just me trying to create threads to make sure you understand that when let me say two processes, two threads try to, or in this case, it's mimicking two people trying to call the same resource, the same class. So two threads try to call the same object, we'll get just one. So we could have T1, start T2, what's that? Let's see. Yeah, so you see what happens is that both threads return exactly the same instances. So you see it's exactly the same up there. Okay? But if we didn't do this and say we did say public here, or let's just say rather than doing all of this returning the same class, we just return a new singleton class. Okay, so if we just comment that out, again, this is identical to when you just create a public constructor. So I'm doing that just so that I should change that code. Then what you realize is that they have two different signatures, right? And indicating two different objects being created. And that's the point of a singleton, right? So we're just going to go back to our previous. And this is kind of the way you want to do it. Again, you could basically just skip this entire if function, and this is why I did the final. You have a new singleton class right there, and make this final, and this makes it immutable. Okay, this makes this particular thing immutable, and so this class will exist. But again, this is evaluating this class, and this will already exist. So you have that, and again, the same issue. If you run it, no matter the amount of time, it's going to just give you exactly the same number, exactly the same thing. So it's the same thing, right? And it's also thread safe, right? It's also thread safe, which is why I use threads to demonstrate this. And you want to use it for issues like, say, when you have something like this, right? You want to like use it with static methods in Java, right? So for globally accessible functions like methods, say you want to calculate, like you want to say write a logger, right? So you want to say a particular logger that logs across the entire application. You could write a global accessible logger. Let's assume that our singleton class is a logger, right? We can now have a public static method called which is a void, which is static void logger, which will take a string and take the message that you want to log, and you can have a system dot out dot print line, and you can now have let's say message, and then just say message, right? And I'm gonna complicate stuff. to say this times our logger class. Goes to that, and our logger. You see the details for our logger dot log hello. Very nice. Okay, and right here we put more just passing our logger. And again, it's about the same thing that's going to happen within our second process, our second thread. Yeah, just the same thing. And this time around, we're going to say hi guys. Okay. And if we run it, what you're going to observe is you get the hi guys and the hello guys, and then the print statement. The behavior, I mean, you're expecting hi, hello, and then the two, but this is thread, this additional data I've done with here. So that is it about Singleton, and I hope that makes sense. Technically, this video had already been done about 10 minutes ago, so the extra 10 minutes was just for demos and explanation. I hope that this makes sense, and I hope that you understand what Singletons are for and their uses and how you could create them. So that's it for today. My name is Gane Emmanuel, and thank you for watching. Thank you for joining the video. Subscribe to the channel, give it a thumbs up, and share the video if you find it useful. And watch other videos, because tomorrow we are going to be talking about the builder pattern. Right? That's it. Have a nice day. See you next video.